We are very close to defining our function to initialize a neural network. We just need to go over two APL primitive functions, and then two operators. And so if you are familiar with table, if you are familiar with table, with drop, with switch and reduce, go ahead and skip this video. Otherwise, I'll start by explaining what drop does, which is actually very simple. So drop is the dyadic version of the downward pointing arrow, and you type this with APL U, as in under. And what you do is you have an array on the right, and then on the left you specify how many elements you want to drop. For example, here I'm dropping the first two elements of this vector. Well, I can also drop, say, the first three elements of this vector, which gives me nothing. Or I can drop the last element of this vector. And dropping from the end of a vector is done with the minus over here. So that's drop. And the next function we care about is the table function, the monadic version of this function over here. And the way you type it is with APL shift and then the key that is to the right of the letter M, as in monkey. In my case it's a comma, so it makes perfect sense that a shifted comma gives this, but in your case it might be different, so check the language bar if you have to. It's right next to the row and to the comma. And what it does is it takes a regular vector on the right and it creates a column vector. And this is very useful because we are going to deal with column vectors a lot. So just to check, the shape of this is a 4, because it's a vector with 4 elements, but then the shape of the table of 1, 2, 3, 4 is 4, 1. That is a matrix with 4 rows and 1 column, which is basically a column vector. So we are going to use table a lot. And then the next thing we care about is the switch operator. The switch operator is very interesting, and the way it works is, well, actually you can type it, let's start with that. You can type it with APL shift T, because this is a modified tilde, and tilde is on APL T. So APL shift T prints this glyph. And what it does is it takes a function on the left, let's say minus, and it switches its arguments. So 1 minus 4 is usually minus 3, but if you switch the arguments, it's actually 3. If you do 2 to the power of 3, you get 8, but if you switch the arguments, you're doing 3 to the power of 2, which is 9. So that's what switch does. And last but not least is the reduce operator, which is the forward slash. And the forward slash, the reduce operator, is very, very useful. And what it does is it takes a function on the left, and then if you give it a vector on the right, it's going to, so this is basically like a fold right, in case you are familiar with other programming languages. Basically what it is doing is taking the function on the left and applying it in between every single element. So plus reduce is actually the sum of the vector. If you do times reduce, you actually multiply all the numbers in the vector, so you could implement the factorial with times reduce. If you do comma reduce and you apply it in a vector of numbers, you can't really tell much of what's going on, but it's taking all these separate elements and concatenating them to create a larger vector, and then it boxes it because it expects a single scalar as a result, and because you're getting a vector you need to box it. But it's just joining everything. This becomes more useful if you look at, say, a bunch of strings. So this is a vector with 3 strings, and if you concatenate reduce them, you get all of the strings together. And there's also another thing about there's many things about the reduce operator that I'm not saying, but one of them is particularly useful, and that is the left argument that I can give the derived function I get. So if I do, for example, 2 plus reduce 1, 2, 3, 4, 5, instead of summing the whole thing, what I'm doing is I'm summing inside windows of size 2. So basically I'm summing pairs of consecutive numbers. I can also do, for example, multiply triplets of consecutive numbers. Or I could create pairs of consecutive numbers, for example. And that's what we are using the reduce for. Well, in the next video at least, we are going to create pairs of consecutive numbers. So feel free to explore the reduce operator and the switch operator and everything you just learned. And also, please bear in mind that I'm just giving the basic usage of each of these primitives. And once you are comfortable with what I just showed you, we can move on.